Right, year 10s. We'll have another go at this one. Second time video. I'll do the other one as well, the scaffolding to a higher than C level, but I'm not exactly kind of like scaffolding. I'm more like giving some hints on how to think and where to think. But this one here, this video is around scaffolding you to a C for the solving aspect, the solving mark in your PSMT. So hopefully by now, or you should, have statistics collected from ATP on two players. I've got two players here, right? They need to be male because of the comment that was made by the commentator regarding how there's a 50-50 chance that any top male tennis player has a 50-50 chance to win a game from 15-40, right? So what we'll do is we'll gather their stats from for their first serve in, winning from first serve, and then winning from second serve. So we'll apply Djokovic's stats to our model that we've made, right? The physical, the graphical model, which describes the outcomes of winning just a particular point, just a single point. So if Djokovic is on 15 and Fed's on 40, that means Fed only needs to win one more point to win the game. So we can't afford Fed to win another point unless, of course, we get to deuce, and then he needs to win two more, but we'll get to that. But what we're going to assume for a C is that the way this game will work is that Djokovic will have to win every point up to the point he wins this particular game. So he will go to 30-40 when he wins the first point, and then he'll go to 40-40, also known as deuce, right? Deuce. He'll go to add, and then he'll win the game. So how many points does he need to win? 15-30, that's 1. 30-40, that's 2. 40 to add, that's 3. Add to game, that's 4. So this model is only describing the probability of winning one point. So we'll need to think next about how we can, extend this idea to 4 games in a row. 4 points in a row, sorry. Let's continue. We'll apply this model, but let's understand first what's going on. These are all the options, these are the options of what can happen when when a point is won. So let's have a look. So after Djokovic serves, it can either go in. Remember, R is first serve in. So first serve in, just getting it in. Just it hits into the appropriate box. Or it doesn't go in. And we call that 1 minus R. All right. So if the percentage here of getting it in, and I can see is 67% for Djokovic, I'll go ahead and write 67% here. And then what percentage left over is 1 minus R, or the percentage or likelihood for him to not get the ball in the first serve. So that would be 33%. That's just 100%. Take away the 67. All right, that's what this is. This is 100. Take away the 67, which I got from here. Okay, done. Let's go next to what happens if Djokovic gets it in. Well, think about it. If it lands in, they're now probably rallying. They're going back and forth, hitting it to each other. The option for Djokovic is either he wins from his first serve. That's what F is, right? Winning from first serve. Or alternatively, he doesn't win. So that 1 minus F. And we know his win percentage is 74%, as observed from the table above. So we'll go ahead and write 74% here. And what's left over, if he's not winning from his first serve, he's not winning. And that would be 26% right here. So again, how I got that was just 100% minus that 74% from above. Okay, let's keep going. The option that he has, if he doesn't get it in on his first go, is that he gets, if he does get it in, the other option is that he doesn't get it in on his first go. Now, if he doesn't get it in on his first go, he gets a second go, right, a second serve, and he'll either win the point from that second serve or he will not win the point from that second serve. Let's apply the probability there. So have a look. Winning from second serve, he wins at 60% of the time. So that's that position there. 60%. And what's left over, not winning from his second serve, would be 40%. This pathway here, so getting it in on the first serve and then winning that point, that leads to a winning of the point. Not getting in on the first serve, but then having another go, getting it in and then winning that point is also the other pathway to winning the point. All right. What we are trying to look for is the probability, ready, that this and this will happen, or this and this will happen. So the first scenario up the top, getting it in and then winning, or not getting it in but then winning from that second serve happening. I've deliberately used the words and and or because they are key ideas that I have taught regarding probability. Okay? And usually in probability implies that you've got multiple events happening, so getting it in on the first serve, winning then. Because there's two events, it's less likely to happen. So we apply the multiplication operative to this word. But because there's also another way of winning a point down the bottom, right? Or implies that there's another option or that the probability of this happening, winning a point, increases. So we use the addition operative for or. But don't forget, for this pathway, there is an and, so there's another times here. So have a look at this. This is what we're going to do. We're gonna write a model, right? A formula, just a straight line of letters that are going to predict the probability of winning a point. All right. So let me just take my cursor and just move it forward for a moment. Okay. And I'll get my pen. So I'll come up here now and I'll start writing here. The probability of actually winning a point. So you can write winning a point or you can just write point below. And this is how I'm going to do it. The probability of a point, okay, is going to be equal to R multiplied by F, or just RF. Or, as we previously just discussed, involves addition, 1 minus R times S. And I'll put 1 minus R in brackets because they're the 1 and the minus R are both multiplying with S. And that's the probability of winning a single point, just a single point, okay? So don't automatically try and substitute. I mean, you can, like it's worth probably communicating, but what I tend to find with students is they just want to put the numbers in straight away. So what's R in this formula? It relates to the first serve in. So you're likely to put your 0.67 in here. And then what's F? That's winning. So you put your 74% in there, or 0.74, and you just want to find out the probability. But that's all well and good. But when you do that, you're just finding the probability of winning a point. And that's not the end. You're not finished yet, all right? So what we actually need to do is work out the probability of 4 points, or a game. 4 points. All right. Think about this. We have to find the probability of winning a point, which is all this, and then doing it again and again, right? And then again. So now we've won 1 point, then a second point, then a third point, and then again. So we need to essentially, ready, all these ands, we need to multiply this model by itself. And how many times are we doing this? Well, once, and then twice, and then 3 times, and then 4 times. So we're going to go ahead and essentially just raise the power of this model to 4. So RF plus 1 minus RS, all to the power of 4. And that's the model for working out or determining the probability of winning a winning a game from 1540. But you're only assuming that Djokovic wins 4 points in a row. Obviously, there are many other ways to win from here. You could win your way to deuce and then go back and forth with Djokovic and Federer going back and forth between ad and deuce, and that's a little bit more complex. So that would garner a higher mark. But I'm just scaffolding the basic, if you can get to this point, and then you can substitute the numbers into R and F, and then 1 minus R and S, which we've got in our model, and then raise it to the power of 4, and then actually get a probability as an answer, then that will garner you a C. You'll get a C for the solving aspect of this PSMT. And that's how I've scaffolded you. So that's the end of this video. Look out for another one where I'm talking about the issue with this model and how you can extend to potentially earn yourself a higher mark for the solving component of the PSMT. All right. Sorry for the delay. Thanks, everyone.